And 3 months later, my team discovered human telomerase. We then right away did the experiments that everybody always dreamed of doing. And that was we put human cells in a petri dish and showed that they not only stopped aging, but their aging was reversed by every method of measurement imaginable.
A little bit about Dr. Andrews. He is the founder and CEO of Sierra Sciences. His PhD is in molecular and population genetics. He has over 50 patents and has published more than 50 scientific papers and even co-discovered human telomerase.
I don't ever want to die. I think aging is the dumbest thing that ever evolved. We don't need to age. It's just complete nonsense. I don't see any reason why we can't just live forever.
Hi, my name is Chris Burris. I'm a longevity expert and the chief scientist at a lab focused on a longevity molecule. My primary focus is to help people live longer and better lives with science. Make sure to subscribe and share so you and your friends can live longer and better, well, actually, so you and your friends can live beyond the norms.
Hi, and welcome to the next episode of the Live Beyond the Norms Health and Longevity Podcast. If your cells had a timer counting down to your death, would you want to stop it? It may be that telomeres are the countdown timer, and today we're focused on how we might extend those telomeres. Our guest today has spent his career chasing something we all secretly want, which is more time. Dr. Bill Andrews is a molecular biologist and longevity researcher best known for his pioneering work on telomeres. The countdown timer I mentioned earlier, that's the telomeres. A little bit about Dr. Andrews. He is the founder and CEO of Sierra Sciences. His PhD is in molecular and population genetics. He has over 50 patents and has published more than 50 scientific papers and even co-discovered human telomerase, the enzyme that can actually lengthen telomeres and potentially reverse aging at the cellular level. Today, we'll go beyond the headlines and talk about where aging research really stands, what breakthroughs are coming next, and how close we might be to slowing or even reversing the biological clock. Dr. Andrews, thank you so much for joining us today.
Thank you. Thank you. I enjoy being here.
All right, so before I jump into your area of expertise, I like to go further back, like much further back. What was it like growing up, little Bill? Where did you grow up? What were your parents like? And if there was some event or someone you could pinpoint as the reason you would ultimately become a longevity expert, what or who would that be?
That definitely, there's no question about it. It's my father. When I was 10 years old, I was very interested in science and medicine. And unbelievably for a 10-year-old kid. My teachers in my elementary school would send me home with notes pinned to my shirt that my parents would read, and they would say, your child is really obsessed with science and medicine. You should nurture this. So I'd already, I've probably a longer answer than you want, but I wanted a telescope for Christmas when I was 10 years old, and my parents got me this toy telescope, and I cried about it. Okay, so they went around in garage sales and found me this really great 4-foot long, 8-inch diameter reflector telescope that I just had a ball with. And I would, run into the house, tell my parents, come on, look at the moons of Jupiter and the rings of Saturn and things like that. So my father came out to the front lawn one day when I was with this telescope, and he said, Bill, since you're so interested in science and medicine, when you grow up, you should become a doctor and find a cure for aging.
Wow. This is approximately 10 years old?
I was 10 years old at the time. And he said, I don't know why nobody's done that yet. Okay, which is something that I'll never, ever forget. And he used the word cure, which a lot of people, especially in the last 20 years, have been ridiculing me for, because they say, well, aging is not a disease, so you can't cure it. Well, I think it is a disease, and I stick with but I stick with it just because my father said that. But my father ended up becoming, so I got obsessed. That became, oh my God, this is what I want to do in life, is I want to cure aging. So all through high school and college, I was starting these anti-aging clubs and having discussions about the theories of aging and things like that. What's, the what, why, how, and how not of aging. And some of the people in these clubs got Nobel Prizes later later, especially like Bruce Boiler, who got the Nobel Prize in Medicine, I think, in 2010. But and he was my best friend in college. But we just, all of us, we just concluded that none of the theories about aging made any sense whatsoever. So I would be going to these anti-aging conferences with my father. Okay, he was a television producer, by the way. He was like the #1 daytime television producer for 7 straight years with all his game shows. He was mostly a game show producer, like You Don't Say, It Takes Two. It's Ralph Andrews Productions.
And where'd you grow up, just for some reference?
Well, born in Michigan, Saginaw, Michigan, but when I was 2 years old, my family moved to Southern California, San Fernando Valley area. So we grew up there because my father was in Hollywood. He started off as a page, just escorting people into audiences, but became a top producer. So I was there during his whole career. But he was obsessed with aging. He used to have bumper stickers saying, "Aging sucks," okay? Because he didn't like getting older. And so he would go to these conferences with me, and he was going to make a documentary on anti-aging. So I introduced him to all the top anti-aging scientists in the world at some of these conferences. But then, unfortunately, he started developing signs of Alzheimer's and passed away from Alzheimer's in 2015, which is a big loss because he was my partner in all this stuff. And there was nobody else I wanted to cure more than my father. But, things didn't happen fast enough, so it didn't happen. But there's still 150,000 people dying of aging every day on this planet. And we have to come up with something fast. And, I'm not in it for the money. When I have a cure for aging, I would love to be able to drop it from airplanes. But I'm sure the marketing company that I license it to isn't going to be happy with that. So they'll probably want to make some money off of it. But
all right,
yeah,
a little bit of more background, right? So you have 2 undergraduate degrees, one in biology, one in psychology, and we may have a lot of the answer that you've provided already. You went on to get your PhD in molecular and population genetics. So why I think we understand biology. How come psychology? That's just extra effort. And then what'd you end up doing your PhD thesis on?
Okay, so this is unusual. Okay, so I was so obsessed and trying to figure out everything about aging that I was like on a scavenger hunt most of my life in schools, trying to figure out what are the things I need to learn? What are the things I need to understand to disprove the theories and stuff like that? When I need to build an arsenal of tools that I really needed. And so when I was a biology major at UC San Diego, I was really disappointed that there were no classes in things like computer modeling, statistical theory, experimental design, looking at results. All the biologists, all they want to do is teach biology. Okay, they didn't want to teach how to be a scientist. And so I remember I went to the counselors at the school and said, I want to learn how to be a really good scientist, and I want to learn how to study all these things. And they said, you should go into the experimental psychology department and take classes there, because there all this work on animals and human studies and stuff like that require a lot of statistics. Not just statistics is one thing, but statistical theory, that's a whole bigger ballgame. Like when I would look at the graph of like the age that people die, you see this, maybe a little bump at the middle because a lot of there's a lot of children who died before getting to be 5. Then it really flat, and then it goes up and it comes down in kind of a sharp peak. Well, what does that tell me? So statistical theory helped me explain that. And so I took a lot of that, but also computer modeling. I mean, tremendous amount of stuff I got from computer modeling, and it made me the best biologist on the planet, as far as I was concerned, because none of the other biologists even knew what math was. I was a math major, by the way, before. I just reached a point where when I was calculating the surface areas of objects in the 7th dimension, I couldn't figure out why would anybody want to know that, but I could do it easily. It was fun, but I had to apply it to something. So, but I ended up taking so many psychology courses, and that includes like cognitive algebra and artificial intelligence and on and on. All these different courses, the statistical theory, computer modeling, things like that. I ended up getting a degree in psychology, even though I was never pursuing one. Okay, so I got a bachelor's degree in psychology and biology.
And then you went on. By the way, I can kind of co-sign. I remember of all the classes that I took, and I took some labs, my degrees in mechanical engineering, and I took different lab classes. But I really do remember in psychology being very interested in kind of the stats behind them proving things, right? So how do you prove that, I don't know, people who believe they're lucky are actually luckier? Like these are amazing and to tease out that information. So it makes perfect sense to me. So PhD usually has a thesis. We had enough of a conversation before that maybe you didn't have a specific thesis, but we talk about kind of how you ended up with your PhD in your molecular and population genetics.
The thesis is for a master's degree. Okay, when you get a PhD, that's a dissertation.
Dissertation, okay.
Now, I decided I didn't want a master's degree. I didn't want to go through all that extra trouble to get a master's degree. So I skipped the master's, but they made me do a what's called a prelims thing where I had to write a study. And what I did is I chose to write a study on the why we age, a mathematical modeling on why we age, the evolutionary perspective and things like that. Why we never evolved a way not to age? Why did we evolve aging to begin with? And so I wrote a really great mathematical modeling challenging a Dr. Charlesworth. He had published a study shortly before then, which I totally disagreed with. And then now one of my best friends was actually a student in his lab at the time. But his name is Mike Rose, Dr. Mike Rose, and I think he's really the smartest person on the planet when it comes to evolution of aging. But I wrote this thesis on, and it wasn't called a thesis, it was called a prelim something. But I wrote it on developing a mathematical model for explaining why we age. And I can come back to that later because that's a remarkable subject. Unfortunately, when I got to graduate school, that was right at the time of the Asilomar conference in California, where they decided to put a moratorium on recombinant DNA research. And that was really disappointing to me because I had already, as an undergraduate, wrote a thesis on how to cure Tay-Sachs disease using gene therapy before gene therapy was even a term. It was a brand new subject and stuff like that. So I was already on the verge of stuff like that, but it turned out I wanted to go do gene therapy in graduate school for the purpose of aging. But I got, every graduate school that accepted me, they told me, well, you can't do recombinant DNA research as a graduate student because of the moratorium from the Asilomar conference. I did go to medical school first, and in two different places, UC San Diego and Jacksonville, Florida. And in both cases, they just frowned on me because all I wanted to do was research. I did not want to work with patients. Well, then, fortunately, one day, because Dan Lindsley, who was my major professor essentially when I was an undergraduate at UC San Diego, where I did a lot of fruit fly experiments on aging with this guy I mentioned before, Bruce Beutler. But he contacted a group of scientists that were boycotting the moratorium and decided to set up shop in the place that would be most under the radar if possible. That was University of Georgia. He contacted them, and then I got a letter from University of Georgia offering me a position as a graduate student there to do all the work I want to do under the boycott the moratorium and stuff like that. And so I just jumped ship and went there. It was the best thing that ever happened. But I wasn't allowed to do it on animals or humans. I had to do it on plants. So I learned a lot of molecular biology studying plants, but also studied evolution and things like that at the same time. That's what population genetics is. Population genetics is the how and why of evolution, not the what and when you normally talk about evolution. So I was doing my PhD in botany, which I wasn't interested in plants at all. But the day before, practically, that I was getting my PhD, the University of Georgia created the molecular and population genetics department just so I could get a PhD in those two fields, because those were the two fields that I had studied the most. So molecular genetics is, you need to know that if you ever want to do anything to control evolution or look at gene expression or change gene expression, all the things that are going on today was molecular genetics. But the understanding of why we age and stuff like that, why we never evolved a way not to age, that was population genetics. And that's why, if people listen to my videos on those subjects of why we age and how we age, I think each of them is like at least an hour long. I go into great detail of explaining exactly that. And I understand it's not a theory. I explain it in a way that requires no theories whatsoever. It's inevitable. There's no way to avoid it. I mean, the theories might be true, but they're unnecessary. Okay, we are going to age even without it. Now, I believe we are now smarter than evolution, and so we can control evolution, control our aging. That's why the molecular biology was so important to me, because that's what I want to do. I want to control, I want to eliminate this whole dumb thing called aging, because what I know about why we age and why we never evolved a way not to age is we didn't need to. It just turned out to be beneficial to the species, but not the individuals. Now, since we're smarter than evolution now, we can control that. I should
And
just
so your goal is actually to fulfill this 10-year-old father's conversation. What an amazing story. You said that you've got 2 videos, and we're going to link to a document where people can find the videos and everything. You said it was 2 one-hour videos approximately. We don't have the time for 2 one-hour videos to insert into here, so keep it really brief, which I know is kind of like hand tying you, but or hog tying you. But why does aging exist?
Well, in order for species to survive in rapidly changing environments, the more diversity that exists within the species, the more likely that some members of that species will survive any rapidly changing environment. So all through evolution, every single change in evolution, and I talk about all the different events in evolution that have occurred, have all been geared towards increasing diversity. And I don't want to say it's geared towards, because that makes evolution sound like a force. Evolution is a result, not a force. But sometimes it's easier to describe it as a force. But it turns out that the more diversity things would survive, the more likely the species would survive. So one of the biggest thing that ever happened in evolution to increase diversity was the evolution of sexual reproduction, because for the first time suddenly we are shuffling our genes. Okay, we also have mutations occurring, things like that, which is adding diversity, but now we're shuffling our genes. It was the fastest thing ever to create diversity within a species. Well, the only thing that could make it that even faster was to eliminate the longer lived. And I don't use the word old. I say eliminate the longer lived. Life's about living. That's why I don't use old. Eliminate the longer lived to increase, by longer lived meaning you've already raised your young. Afterward, you're not useful to the species. By eliminating you decrease the chances of parents rebreeding, which is not going to add anywhere near as much diversity as letting the offspring interbreed. Okay, so any species that didn't eliminate the longer lived had a less chance of surviving rapidly changing environments. And that's why today most animals have some form of way of eliminating the longer lived, and we all call it the aging process. Sometimes it has nothing to do with aging. In fact, humans, what I've concluded is humans, what we evolved as a way to eliminate the longer lived was telomere shortening. But other animals, in fact, there's only, let me say, a few animals like humans, most non-human primates, dogs, cats, horses, sheep, pig, and deer. They're the only animals that actually do age by telomere shortening. Rodents don't. Mice, rats, rabbits, they don't age by telomere shortening. But there's been, I might, if we have time later, there's been some animals that have been engineered. It's like mice have been engineered to age by telomere shortening. And so a lot of studies have come out of that. I think you wanted a short answer. Have I already gone way over time on short?
No, I think that's good. I just have, so I've always pictured aging as the junk that's left over because you've already served your species purpose, right? And we, some debate saying once you've become even getting to be a grandparent could add value to making sure that the child is reared, right? And then the rest is just junk that there's been no reason to get rid of it. And you're actually saying, there's a positive force kind of going on, force function, that's saying, hey, not only is it just kind of this genetic slop that there's no reason to get rid of, it's actually a forcing function to get you out so that, one, to end your reproductive time so that you don't continue to populate with basically the same genetics. So it's a more, again, it's not a pushing function, it's a pulled function, but it's more proactive in that sense.
Yeah. And everything else is true, like accumulation of junk, accumulation of DNA mutations, all that's happening at the same time. But our bodies actually have the ability to clean that out, mostly because of cell division. But the problem with cell division is that human cells can only divide a limited number of times. That's the Hayflick limit. And the Hayflick limit is caused by telomere shortening. And so I always say, I don't want to say that none of the theories are true, but I can say that no matter what else we do to try to cure aging, we will never succeed at curing aging unless we also solve the telomere shortening problem, because that's the only one of all the, and I don't want to call it telomere biology shortening a theory, because it's not a theory anymore. That's an absolute fact that everybody knows. If we do anything else to try to solve the aging process, we still have this hard, fast brick wall that we run into from telomere shortening. And when we get a chance to talk about telomeres more in general, I'll explain the details of that more. But when we do solve the telomere shortening problem, I hope that adds 20 to 30 years on my life so that I can work on solving the other problems that might exist. But like oxidative stress is clearly a problem with aging in mice, oxidative stress and mitochondrial dysfunction, but humans have 100 times more natural antioxidants and stuff than mice do. So oxidative stress might be something that might, cause us to die of old age when we're 200 years old. Who knows? But right now, it's telomere shortening is the thing that's really limiting our lifespan the most.
All right, let's get into telomeres, right? So
Okay.
one, how'd you end up starting to study telomeres? Like, how did they come onto your radar, right? Because you are on a boy, now man, on a mission to solve aging, and this lands in your lap, or you seek it out, and then what are let's dig into what are telomeres and more.
When I was still in college and I had my anti-aging clubs, we would discuss, what's causing aging, and nothing made sense. I always say all the twos and twos have to add up. Okay, the environmental kind of things wouldn't explain why dogs and cats age at a different rate than humans, or why people at the North Pole and South Pole age at the same rate as people who live on the equator. There's just too many things that didn't make sense. Okay, so the Hayflick limit was announced in 1961, that human cells can only divide a certain number of times, and most people boo-ha-ha'd it, didn't believe it. But we actually decided, boy, this actually makes a lot of sense, and it was the only thing that ever came along that explained all the twos and twos about aging. But here's the thing: how could a cell know how many times it has divided? How many times it has left to divide? When cells don't have brains, they can't count, stuff like that. So we concluded, when I was still in college, that there had to be something like ride tickets at an amusement park. Okay, that every time a cell divided, it lost a ticket. Just like when you go to a ride, you go to an amusement park, your parents give you tickets. You can count the number of tickets you have, things like that. But the most important thing is when you lose your last ticket, you can't go on any more rides. So we thought something in cells was like that. But what was that? We couldn't think of any biochemical mechanism that was those rye tickets at an amusement park, but we also couldn't think of any other biochemical mechanism besides rye tickets at an amusement park. It had to be that. So when I got to graduate school, when I got my PhD and I applied to every anti-aging lab in the world and got accepted to them all, and to do my postdoc work, and I went and interviewed them to see if I wanted to go there, none of them made any sense. And so I just decided they didn't believe in this ride tickets and amusement park idea. And so I went into biotech instead. But then, I want to say 12 years later, my father and I were at this conference, and I heard somebody talk about the fact that telomeres shorten every single time a cell divides. And that guy was Dr. Calvin Harley. And he had just been hired as the chief scientific officer at Geron Corporation. And I went up to him before he even got off the podium, and I said, has somebody figured out how to add more ride tickets back? Because that would be, from my scientific training and stuff like that, to prove something, you got to reverse it. Then you got to do a process called extinction where you unreverse it, things like that. And so I thought if somebody could figure out a way to re-lengthen the telomeres or add ride tickets back, that would provide proof that telomeres had something to do with aging. And he said, no, we've been working on it for years, have had zero success at all. We've been collaborating with labs all over the world and haven't had any success at figuring that out at all. And I just said, let me come and work with you and I'll have it figured out in 3 months. And shortest job interview, he let me do it because I'd already had a very successful career in biotech, being an inventor of a lot of the big blockbusters in cancer, heart disease, inflammation, all kinds of different things, dwarfism, multiple sclerosis. So I had a pretty successful career. So he offered me the job, and 3 months later, my team discovered human telomerase. And we then right away did the experiments that everybody always dreamed of doing. And that was we put it into human cells in a petri dish and showed that they not only stopped aging, but their aging was reversed by every method of measurement imaginable. And there was no and it totally abolished the Hayflick limit, which is the limited number of life cells times the cells can divide, which proves that telomere shortening is the cause of the limit on our lifespans. We then grew skin on the back of a mouse, human skin on the back of a mouse, and showed that telomerase reversed aging in every way imaginable there too. And then Dr. Ron DePinel, using our technology, he had already created engineered mice that I mentioned mice don't age by telomere shortening, but he created a mouse strain that did. And these mice would get old just like humans get old, and you could see all the changes. But he was able to introduce telomerase and show that they had what he called a remarkable reversal of the aging process. And that's a quote from an interview that Diane Sawyer did with him that anybody can Google and find. Diane Sawyer and Dr. Ron DePinel, telomere biology, and they can find the study where he actually shows these mice having real age reversal.
How was he introducing telomerase? Like, so you've got an animal model, potentially easy in a petri dish. You could correct me, but now you're actually trying to introduce it into the animal to ostensibly have some systemic availability and impact.
The way that Dr. Ron DePinel did this was, well, okay, so I've been an expert in gene therapy since the 1970s, mid 1970s. In fact, I wrote a thesis when I was still an undergraduate on how to cure Tay-Sachs disease using gene therapy, and almost, went to work in a gene therapy lab at UC San Francisco with Mike Bishop. So when we first discovered telomerase, the very first thing I did was to create gene therapies for delivering the gene. So when I say that we added telomerase to cells in a petri dish, we infected the cells with a virus that carried the telomerase gene in, and the gene was turbocharged. This is one from my molecular biology. I learned how to really turn on genes to the maximum. So put these insert the turbocharged telomerase genes into the cell, so they produced a lot of telomerase. That's why we saw the reversal of aging. So that's what Dr. Rhonda Pinnell did first too. But he first had to engineer mice to make it so that they did have telomere shortening, because mice, rabbits, rodents, and a lot of animals have telomeres already produced in all their cells. Okay, they don't have telomere shortening, and so he had to first create a mouse that didn't have telomeres produced. So he shut off the telomerase gene. Telomeres got really short, and then he started seeing that these mice started aging just like humans, male pattern baldness, all kinds of things similar. Then he used the gene therapy to reintroduce telomerase to the cells, and saw what this remarkable reversal of the aging process. Hair color, hair coming back. The biggest surprise was mice being able to remember how to go through a maze again. The mice that were suffering from dementia, maybe something similar to Alzheimer's. It's now when I go to medical conferences on especially brain disorders and things like that, I hear everybody saying that Alzheimer's and other forms of dementia are most likely not the loss of memory. They're loss of access to the memory. And telomeres, lengthening telomeres, might restore that access. So I actually have a clinical study in clinicaltrials.gov where I'm trying to get a clinical study started to actually look at lengthening telomeres as a way of curing Alzheimer's. Unfortunately, gene therapy is very expensive. I mean, it costs $1 million. It cost me $1 million to treat one person once.
Wow.
And it's also risky. Okay, so we would only do it on people that had no other choice.
Yeah.
So that's what Dr. Rhonda Pinnell did. He used gene therapy to deliver the telomerase gene to the mice, and saw that remarkable reversal of the aging process.
So before he's genetically modified these mice so that their telomeres shrink, mice do age, right? Like they don't age via telomere shortening, right? They age. Do we understand the mechanisms that they tend to age in?
I don't think we totally understand it, but we do know that they have extremely high oxidative stress and high mitochondria dysfunction. And so those are probably playing a role, but they're way, way higher than humans. And I think the only people that actually...
that supports your idea that if we solve this telomere shortening, we may just be pushing out to the next problem, right? Which might be this oxidative stress, which is the thing that ultimately takes out a lot of other animals.
Yes, and it does take out a lot of humans that lead poor lifestyles. Okay.
Yeah.
So if you take your antioxidants and you live an antioxidant lifestyle, same with anti-inflammatory lifestyle, telomere shortening is the thing that's going to get rid of you, not oxidative stress and mitochondrial dysfunction or inflammation. But that's how a lot of happen. Now, my company has been since gene therapy is risky. There's been a lot of clinical studies done on gene therapy where half the people in the study died, because of the gene therapy causing cancer. Like most gene therapies integrate into the chromosomes randomly. And if they integrate into a gene that is like a tumor suppressor or oncogene, they will give that person cancer. And that's what happened. In fact, it's one of my reasons why I really frown on the FDA, the fact that they even allowed such studies to happen, because anybody with a molecular biology 101 background will know that gene therapy with a virus that integrates into the chromosome integrates randomly, is going to give that person cancer almost for sure. And that's exactly what happened. And the fact that the FDA approved it it makes me very disapproving of the FDA on that kind of stuff. I often will say at conferences that I don't think the FDA is qualified to be overseeing safety. I think that falls under the shoulders of the principal investigators, things like that. And then you can't even trust all of them.
As it turns out in some cases, yeah. So, so you were doing gene therapy work back in the 70s. So, in my mind, this SNP protocol, right, this kind of accurate process of adjusting genes is relatively recent. So, you were using maybe a more arcane, or do I have the timing wrong?
Okay, by SNP, I think you meant CRISPR.
CRISPR. That's exactly what I meant.
Yeah, well, CRISPR, that there's so many buzzwords in the world. CRISPR is like touted as the very first gene editing protocol ever, but we were using zinc fingers for gene editing for 10 years before that. And I talked to the discoverer of zinc fingers one time, and I said, does it bother you that CRISPR's actually saying they're the first? And he says, yeah, it bothers us, but we're not going to do anything about it. We're not in it for the money or the publicity. We just want to cure diseases and make people happier and healthier, which is good. But CRISPR is, we don't use CRISPR here. We use zinc fingers. I mean, zinc fingers work great. There was also another protocol that came out called TALENs, TALENS, that works really good too. But we weren't really doing gene editing inside of humans. All the gene editing we were doing was through a process that I patented years ago called high throughput in vitro mutagenesis, where I could make 100 different mutants a day of any kind of gene. And we were engineering the telomerase gene in the test tube to create a turbocharged gene, and then using that and inserting that into the cells. So we weren't actually engineering, we weren't genetically modifying or editing the genes in the cell. We were editing them before putting them into the cell. But we also have done a lot of gene editing in the cell using zinc fingers.
Hey, super quick break from the podcast. Hopefully you're loving it. This is a way you can support the podcast and take advantage of a great offer. We're offering 50% off of one of our MCT bottles. MCT is an amazing oil. Add the ESS60 molecule to it. It's even more amazing. All you got to do is leave a review on iTunes, send us a notification that you've left that review. We'll get you a coupon code that'll get you 50% off of our MCT oil and free shipping. Back to the podcast.
So one question: could we just inject telomerase? Like this is something clearly you're getting to the gene level. Why can't we drink it? Like I know there's lots of but talk about that a little, please.
Well, I'll tell you, there are products that claim that, but telomerase is too big. The molecule is too big to get inside the cell. I mean, and it's a protein. It's actually made of a protein and an RNA component, but that protein gets degraded the second it gets in your stomach. You can inject it into the blood, but it still can't get into your cells.
Okay.
It'll probably still be degraded in your blood. You have to get the gene into the cell, and then have that gene produce telomerase inside the cell. Or that's what my company is trying to do. We are trying to find molecules, like especially nutraceuticals, molecules of nutraceuticals that will get inside your cells and attack the gene to turn it on. So attack is the wrong word, but the gene is shut off. The telomerase gene is shut off in all of our cells so that we eliminate the longer lived. That's what we do. There's these proteins called repressors that will bind to the dimmer switch that turns the gene on and off, and it shuts the gene off. So we're looking for molecules that will bind to those repressors, dislodge them, and allow the gene to turn on. And we've found over 1,000 different molecules that would do that so far. We just haven't found any that turn it off enough remove the repressor enough to actually produce enough telomerase to reverse aging, okay, to be as efficient as is found in gene therapy or in our reproductive cells. I think I haven't said this yet, but the reason why the way we discovered telomerase to begin with was realizing that if every time a cell divided, the telomeres got a little shorter, how is it that our children are born with long telomeres as we had when we were born, or longer telomeres than we have when we actually conceived them? So we knew that in our reproductive cells, the primordial germ cells are also called, the cells that produce our sperm and our eggs, there had to be some mechanism that prevented the telomere shortening every time the cell's divided. And we discovered this enzyme telomerase. Now, the fact that our reproductive cells had telomerase meant that all of the cells in our body had the gene for producing telomerase. It was just shut off. Okay, so now what I'm trying to do is I'm trying to find ways of de-repressing that telomerase gene to turn it back on. And we have had major success. The research costs us $2 million a month to do this screening with these $1 million high throughput robotic screening systems, assays, medicinal chemistry departments, protein chemistry departments, molecular biology departments. It's a big effort to do this. But we have found over 1,000 different molecules now that will do this, but all of varying levels of potency. Okay, so we haven't found anything. Okay, so I'm going to do the tug of war analogy here.
Yeah.
In our reproductive cells, there's telomere shortening and telomere lengthening. Okay, it's a tug of war. So first the cells divide, the telomeres get a little shorter, and then the enzyme telomerase comes in and re-lengthens it. And it's a tie. The tug of war is a tie in our reproductive cells. In all the other cells of our body, we only have the shorteners. So every time a cell divides, the telomeres get a little shorter, then shorter, then shorter every time a cell divides. Our nutraceuticals that we have discovered are adding people to the other side of the tug of war to actually lengthen, but they're not lengthening as much as the shorteners are still shortening. So we're still losing the tug of war, but we're losing it slow. Okay, so this is the first product. Well, okay, I'm going to qualify this and say this is the first product that ever has come up that actually decreases the rate of aging by decreasing the rate of aging, period. Okay, but it does so by decreasing the rate of telomere shortening. Now, I'm going to I'll come back to that in a second, but I just want to qualify that we do have the shorteners pulling to shorten. We can add more people to that side of the tug of war, which is what all of us do. Anything that's related to a poor lifestyle or poor genetics or anything like that will actually add people by adding things that cause oxidative damage, inflammation. All these things accelerate telomere shortening. Now, we can undo that to some extent, with antioxidants such as C60 or anti-inflammatories, vitamin D, omega-3 fatty acids. There's a bunch of them that can actually reduce the number of people pulling. So I call it reducing accelerated telomere shortening. But we can't get it below what's called a basal level rate of telomere shortening that is caused by something called the end replication problem, which is, in my videos, I explain this in more detail, but it's every time a cell divides, the telomeres get shorter by 40 bases. Okay, DNA is made up of bases, and it's like a ride ticket at an amusement park. It's equivalent to 40 bases. That end replication problem is not chewing the DNA away. It's just that when the new DNA molecule gets made, when a cell divides to make two daughter cells, everything needs to be duplicated so that daughter cells are identical. But our cells lack the ability to duplicate or replicate the DNA all the way to the very end. So the original DNA doesn't get degraded. The new DNA that gets made just didn't get made all the way to the end. So it's made shorter. So telomeres don't shorten by degradation and unraveling and things like that, like you often hear. They're shortened by the end replication problem. And we can't undo that by antioxidants, anti-inflammatories, good lifestyle, things like that. To reduce the end replication problem, we have to induce the production of telomerase. And that's what the things that we have discovered does. And I know we haven't gotten there yet, but I just want to say that a company called Touchtone Essentials has recently launched a product called Telovital that contains the most potent nutraceuticals that we've ever discovered at inducing telomerase expression. So this product, Telovital, it's the best way to, and might be the only way, to actually induce enough telomerase to start pulling on the other side of the tug of war to at least slow down the rate of telomere shortening. There's nothing on the planet that actually wins the tug of war except for telomerase gene therapy, which I mentioned before. But we're getting there. I'm continuing my research. I am looking for more and more potent things. And I'm super impressed with this company called Touchstone Essentials. So it's most likely that when we do find more and more potent things to induce telomerase, we'll be licensing them or providing them without a license probably to Touchstone Essentials to market, because we're not a marketing company. We just do research. We're basic discovery research, and I don't want to get distracted from the research by doing something like marketing. So when we discover something, we license it. I use that word license again, but we usually don't license. We just provide it to any company that wants to market it. But that's what's going on there. But TeloVital, I do encourage people. I've got a lot of pride. I'm very proud of this discovery. I think it's probably the best thing that anybody could be taking to decrease the rate of their aging.
So let me see if I can understand this, can unwrap this a little bit. So you've got your cell, it's replicating to create daughter cells. As it's replicating, it's losing a ticket, right? And if you smoke and drink and do dumb stuff, right, you lose more tickets on each replication.
Yes, you accelerate the use of ride tickets.
So you end up, it costs more tickets to ride the ride drunk than it does to ride the ride sober, right? I think that may be a good example. Yes. And then telomerase, which is best augmented with gene therapy, can actually stack tickets back on, right? Yes. So you've seen this in animal models, and it's a gene therapy, so it's not a viable technology in humans to be taking something like this. Or is this something you could get through a physician or a longevity physician or something?
There are clinical studies. As I said, I have a clinical study, but it costs us $1 million per treat one person once. That's because of all the tests we want to do. Now, there are other companies, and I would recommend, if anybody really wants to try it, go to BioViva, BioViva. It's run by Elizabeth Parrish, and she is actually working with companies down in Mexico, I think, or Colombia, where they're actually treating people in clinical studies right now. But that would be the way to go there. It's just that it's a risky thing to do. So it's
cutting edge. Like it's extremely like there are things that are like, we don't have much research on this, and then there are things like we don't have enough research, and it could be harmful.
I will say though that they have overcome the problem that they used to have with gene therapy. Their gene therapy does not integrate in the DNA, does not cause cancer, but it still has possible immunogenic problems, things like that. But I think if I was told that I had 1 year to live because of Alzheimer's and stuff like that, I would definitely get into a clinical study like that.
So we've got the drunkenness, or the bad oxidative stressful lifestyle, and even genetics, right? So if your genetics are predisposed to higher oxidative stress, then you're paying more tickets each time you get this replication. Telomerase can put it back, and then there are some compounds, and you're talking about one compound out of Touchstone, right? Essentials, that they're actually putting some of the tickets back. Is that what you think is going on? And so it's stimulating telomerase, but we maybe have the wrong example. It takes 10 tickets to ride the ride, and Touchstone Essentials product actually adds 2 back.
Something like that. Yes. We don't know the exact numbers. We just know that it is expressing the enzyme, the gene for telomerase, the gene for the enzyme telomerase.
And that telomerase tends to put back the tickets. Okay, so I think I've got that quick. My first comment is you should hurry up. Like we.
Yes. Well, the only obstacle is funding. We know exactly what to do. It's just that I said it costs us $2 million a month to do that, and especially since COVID, it's been hard to come up with that kind of funding. So, Touchstone Essentials is marketing this product called TeloVital, and what I'm excited about is it's actually USDA organic. It's the first product that I've ever had any involvement with at all that got that kind of classification, which is really good. It's all organic and it's vegan, and it's really good. And the ingredients are all written on the side of the bottle here. The most active ingredient is actually turmeric root, but it's a fraction. It's not the whole plant. So when we do whenever we test whole plant extracts, we never find anything that induces telomerase, and that's because we believe a plant extract typically has about 200,000 different types of molecules in it. So some of these molecules might be inducing the telomerase gene to turn on, but others are inhibiting telomerase. So we have to make fractions. So we separate the molecules in terms of size and solubility and charge and a bunch of other things. And typically when we test any kind of plant extract, we'll test like 30 different fractions. And the fractions will contain maybe 10,000 different molecules. There's only one molecule in there that is actually inducing the expression of telomerase, but it's still, at least it's separated the inhibitors. Well, this one fraction of turmeric that did work, and it's the most potent that we've ever seen any place on the planet. It actually is missing curcumin. Okay, curcumin was one of the things separated out of there, but I don't believe curcumin is the thing that we eliminated that was needed to be eliminated. I think that just got eliminated by accident. So we do say turmeric root extract curcumin free. So I think the only reason Touchstone put that in is because they want people to still get their curcumin from some other source. Okay, just in case, the small chance that curcumin is what's preventing the other fractions from working, it might be good to take your curcumin in the morning and Televital at night, or vice versa, or like separate the two by 4 hours or something like that. But it is kind of interesting that the strongest, most potent nutraceutical we've ever discovered was turmeric without curcumin in it. Other things include extract of pomegranate, extract of skullcap, hazy fruit, gallnuts. And then, as I mentioned, you can reduce people on the other side of the tug of war, the antioxidants and anti-inflammatories, to make it USDA. It had to be from plants. And so we're using wheatgrass powder, black currant extract, which both have antioxidant and anti-inflammatory properties. And then there's also black pepper in here that just makes it more bioavailable. But black pepper also has antioxidant and anti-inflammatory properties. There's not a single word on here that says proprietary blend. Touchstone Essentials, it's one of the reasons I like about Touchstones, is they're not trying to compete with anybody. I mean, if you can get these things from somebody else, they're welcome to it. But you wouldn't be able to get the same fractions. It'd be hard to get those because it's a lot of work. That's why I was saying it costs us $2 million a month to do this kind of research. It's not cheap. But this product is actually very affordable relative to other products like it in the past. I don't know any source where you can buy it for less than this, but it is expensive to make. And so Touchstone Essentials is like not that concerned about profit margins. They just want to have a product that really works.
That I think that's a great focus. I had a couple of questions, and then we got to get into our wrap up. We've gone. Okay. This has been a great conversation. I love the pacing and everything. We might have to reconvene. One of them is, as telomerase is adding to the telomeres, right? Adding length. Is it just junk that's good? Like what is it adding, right? And I've got this picture of tickets, but is it, what is a ticket? I guess is maybe the question that I'm asking.
Telomeres are made up of a repeat sequence. So DNA is made up of bases. They're like beads on a string. There's 4 different types of bases, and it's the sequence of the bases that actually tell us what hair color we have, what eye color we have, all kinds of things about us. But at the very tips of our telomeres, or chromosomes, are the telomeres. And I want you to think of this like this long string of beads as a shoelace. At the caps of your shoelaces are these aglets that protect your shoelaces. Well, the telomeres are the aglets of our chromosomes. They're made up of a sequence that's TTAGGG. The bases, that's what the bases are, T, A, G, and C. But the sequence is TAAGGG, TTAGGG, TTAGGG. Each one's a 6-base repeat. It turns out each ride ticket is the equivalent of 40 of those bases. When we are conceived, when we're a single cell inside our mother's womb, we have 250 ride tickets. This is why I say this is not a theory. We can calculate this. We can measure this. We are conceived at, we have 250 ride tickets. And every time our cells divide, we lose a ticket. There's so many cell divisions from going from a single cell embryo to a newborn baby that by the time you're born, you've already used up half those tickets. So you have 125 tickets left. So now we still have a lot of growing to do, wounds to heal, infections to fight, all kinds of cell division going on in our body throughout our life, that we are still losing tickets to the point of where we can calculate that we have a theoretical maximum lifespan of 125 years, no matter how many antioxidants you take, anti-inflammatories, no matter how healthy your lifestyle is, you cannot live longer than 125 years. And I want to live longer than 125 years. Okay, so that's what. So when telomerase adds ride tickets back, it is actually adding the TTAGGG, TTAGGGs. And in my videos, I show actually how that enzyme is working to add those things back. So it's identical. And, there's no such thing as adding too much. Okay, there's some studies that have come out that have kind of claimed that you can add too much. But the only thing that they would report that was a problem was that when the telomeres got really a lot longer than, so I keep my hands in the photo, a lot longer than when you're first conceived, the length, so 250 ride tickets, when you add more, you just lose them faster. But when you get back to 255, it goes back to normal. So it's like nobody's ever found any reason not to make them really long. Now, some people will say telomerase causes cancer. It's just completely not true. I mean, it's like I was national inventor of the national inventor of the year for my cancer research in the United States. So I do know a lot about cancer. I've actually developed a lot of cancer drugs. One just got approved by the FDA called Rytelo, R-Y-T-E-L-O. I'm the inventor of that. I do know a lot about cancer. And I think a lot of these people that are claiming that telomerase causes cancer, they just don't understand cancer. There's a video in the video list you said where I talk about telomerase does not cause cancer. And I spend a lot of time explaining it in detail. But there's some people say making telomeres really long only increases risk of cancer, but it actually decreases the risk of cancer because it's short telomeres that cause mutations, rates to skyrocket, and it's it's mutations that cause cancer. Every cancer that's ever been discovered was caused by a mutation. So lengthening telomeres decreases the risk of cancer, increases your ability of your immune system to fight cancer, which is our best defense against cancer, our best natural defense against cancer. And it also, and when you let telomeres get really short, it makes it so that the cancers can mutate so fast it can even find ways for the cancer to survive any chemotherapy you use. That's why cancers come back all the time. Okay, it's because the telomeres got really short. So keeping telomeres long will increase the chances that chemotherapies will work if you already have cancer. It's just, there's nothing wrong with making telomeres too long. It's it's all good. Bad things happen when telomeres get short. Nothing bad happens when they get long.
Excellent. This has been a fascinating question. I did have one more thing. I think we're going to end up doing work. You know, I work with a molecule. Carbon 60 is, in my mind, the industrial version. We really think of ESS 60 as carbon 60 processed for people and pets. Hopefully we can do some work together on that. And I know you have looked at that in the past, and maybe it's questionable whether it might have an impact on telomeres. I want to maybe work with you to figure that out directly. I think the conclusion at this point is it doesn't, but it might have other impacts, meaning it might slow down the tickets.
I definitely think it slows down the ticket. I mean, just like any antioxidants, and nothing binds more free radicals than C60 that I know of. So it should be decreasing the rate of telomere shortening caused by accelerated telomere shortening. Yeah, so combination, I would be taking something like C60 in combination with Telovital to remove extra shorteners and add lengtheners, okay, simultaneously.
Yeah, makes sense. All right, well, let's get into our wrap-up questions. Dr. Andrews, do you have a target age that you want to live to?
I never want to die. I mean, a lot of my videos, I talk about how I'm not afraid of dying. I'm just afraid of missing out on all the great things that are going to happen in the future. I actually show pictures of myself, but I show pictures of Star Trek First Contact with, I forget the actor's name suddenly, but the two actors that finally shake hands when Vulcans land on Earth to meet the inventor of warp drive. I can't remember any of their names suddenly, but they shake hands. Well, I was at my videos, and you can see this, anybody can see these watching them. At the beginning, I'll say, I'm not afraid of dying, I'm afraid of missing out. When we actually make first contact, I want to be there. And I suddenly superimpose myself in the picture doing a three-way handshake with them. But I don't ever want to die. I think aging is the dumbest thing that ever evolved. We don't need to age. It's just complete nonsense. I don't see any reason why we can't just live forever. We're definitely going to be knocked off by asteroids hitting us or things like that. But I also believe, and I'm glad that there's other people like Dr. Randy Kone, which is somebody else you might want to interview. He's actually working on whole brain emulation, which is another word is called brain uploading. So even in the future, when we run our car off a cliff, while we're flying down to hit those rocks at the bottom, our brain's being uploaded to a computer. Okay, and next thing, and then somebody goes down and collects a few of our cells from the damaged body down at the bottom of the cliff, clones that into another perfect copy of us, and then uploads or downloads the computer into the brain, and we're back again. I mean, some people will say, well, that's not really you. You don't have a soul or something like that. But I'll tell you, I don't know the answer to that question, but I would rather have that happen than totally be lying at that back at the bottom of that cliff with nothing else going on.
So we don't necessarily need to use Brian Johnson's kind of moniker, but do not die is kind of where you sit. How long do you think humans can live? And now, that kind of answers the question. Maybe it's a two-parter. What do you think?
Right now, it's maximum 125 years. Until we solve the telomere shortening problem, it is absolutely mathematically calculatable to show that a human leading the perfect lifestyle and the perfect genetics cannot live longer than 125 years just because of the telomere shortening problem. After we solve that problem, I don't know. But I hope to have another 30, 40 years to be able to do research to solve whatever hits us
next problem. Yeah.
I often think of we age because of multiple sticks of dynamite burning inside of our cells. But which stick of dynamite has the shortest fuse? In humans, dogs, cats, horses, sheep, pig, and deer, and non-human primates, it's telomere shortening. In other animals like rodents and things like that, it's oxidative stress or mitochondrial dysfunction or something like that. Then there's animals that have no detectable aging, like lobsters, tortoises, humpback whales, clams. And clams are the only ones that have rings on a tree that you can count. They have stripes on their shells. There's clams that have been found to be over 500 years old. All these animals that have no detectable aging, by the way, they have telomeres produced in all their cells. They have no telomere shortening. They have no detectable aging. and they rarely ever get diseases such as cancer or other things. So I want to be like a lobster.
All right. What are 2 to 3 protocols, habits, mindsets, let's call them shortcuts, to longevity and a long health span that you would share?
Well, exercise, keep it fun. But anti-inflammatories, antioxidants, vitamin D, omega-3 fatty acids. I'm just trying to think of like everything that I do, meditate, all these things decrease the rate of accelerated telomere shortening, decrease the rate of aging. But don't smoke. Don't be obese. Drinking alcohol, I mean, that accelerates the rate of you losing liver cells. We all know that alcohol kills liver cells. That's okay when we're young, because we have other cells that I call reserve cells to replace the frontline cells that get killed off from the alcohol. But it's only causing accelerated cell division, which is called an accelerated telomere shortening. And so when you turn out to be 40 or 50, you can't replace the dead cells anymore, and you die of liver cirrhosis. I mean, so that's aging of a particular organ, but that's what alcohol does to you. Smoking does the same thing to a lot of tissues, especially the lungs. So I'm trying. There's so many different things.
Well, we've got a few. That's good.
Yeah. Okay.
Thank
Good.
you. What are 1 to 2 things people get absolutely wrong regarding longevity and a long health span?
Well, I would say the major thing is that studying mice is something that is not really helping us understand human aging. Mice just don't age like humans. Same with fruit flies. The imagination that jellyfish who live forever, we could learn something from jellyfish, when jellyfish are really just a colony of cells. They're not a real animal. So people, when they read studies and hear about a product and it says extended lifespan of mice and things like that, saying that that's going to extend their lifespan, that's just not true, necessarily.
All right, Dr. Andrews, how can people contact you?
I actually enjoy reading emails and answering questions. So people are welcome to email me at B as in boy Andrews, so BANDREWS at SierraSci, SIERRASCI.com.
Excellent. And what in the near future are you excited about?
Mostly the idea that if we continue the research we've got going, we could have some nutraceutical, something like a nutraceutical that would actually be potent enough to reverse aging in 1 to 3 years from now, if we just had the amount of funding. As I said, funding is the obstacle, not the science. We know exactly what to do. Just finding that funding all the time is a real challenge.
Excellent. All right. Well, you can find him. Send him an email at bandrews, B as in boy, actually B as in Bill, Andrews at SierraSci.com. Dr. Andrews, thank you so much for joining us today.
Well, thank you.
I hope you enjoyed this episode of the Live Beyond the Norms podcast. Make sure to subscribe and follow. Also, make sure not to be that guy, the guy sharing this podcast with people who are not interested in living beyond the norms. If you would like to learn more about the ESS60 molecule, the molecule responsible for the single longest longevity experimental result on mammals in history, a full 90% extension of life, visit myvitalc.com. That's myvitalc as in carbon.com.